Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And as I alluded to in the daily weather update, this is going to be a one-on-one discussion. You're going to see my ugly mug up here for the entire duration of this video. And I'm going to pretend like we're in a hallway and at work or wherever, grocery store, and we're just having a one-on-one discussion standing there. And I hope that at least with regard to this topic, that it'll help things make more sense. But the topic is ensembles, and I think that over the years, myself and many other meteorologists on television maybe haven't done all that good of a job of explaining exactly what this is and why it's useful in weather forecasting, because I think the perception is that maybe it's not. So I'm going to start off by talking about what is a model. Now, there are different types of models. There are human beings that model different types of clothing. We're not talking about that here, okay? We're talking about a mathematical model that uses mathematical equations to mimic all of the processes, the best science we know of in the entire world up to this date. Okay, those mathematical equations simulate that science, laws of physics, laws of thermodynamics, every process that we know of. And so those mathematical equations are the way that we describe the atmosphere. I mean, math is the language of science, if you will. So every model starts off with an analysis, and the analysis is based on observations. Now, back in the old days, all we had were surface-based weather observations, which is a problem, or was a problem, because 3/4 of the Earth is covered by water. So if you only have ground observations on 25% of the Earth, and those observations are pretty far apart, and they only report once an hour, how are you going to come up with a perfect or near perfect analysis of the entire globe? You don't. Now, we also had weather balloons, but that's even worse because they are only launched over land for the most part. There may be a couple launched over the ocean, but not many, and from islands and that kind of thing. And the problem with that is that they're only sent up twice a day, and they're even farther apart than the surface weather observations are, okay? So we've done a good job over the years of filling in those holes to the extent possible. How have we done that? Remote sensing. What do I mean by that? Radar, satellite, wind profilers, whole bunch of different ways of monitoring the atmosphere without actually having a human being there to take an observation. But even with all that, we cannot observe the atmosphere perfectly, right down to the square inch, all the way around the globe. Can't do it. And so there's always inherent error in a model analysis, what we call the initial conditions. And so those errors are only going to multiply with time. That's why a 3-day forecast isn't as good as a 1, 5 isn't as good as a 3, 7 isn't as good as a 5. And so as a result of that, those small errors at the beginning can have a big impact down the road, okay? And if I could digress for just a second here, if you are a person of faith, sometimes I hear people almost view science as the enemy because they don't think that science is consistent with their faith. I've never looked at it that way. I've always looked at science as the discovery of creation. And so every time we learn about a new law of physics or thermodynamics or whatever, what better way to glorify the Creator than to learn over time how complex all of this is and how it works together. To me, I come to the conclusion that whoever set this whole thing up, pretty smart. Now, if you're not a person of faith and you don't look at it that way, that's fine, okay? I'm not making a judgment here or anything, but I'm just telling you, sharing with you the way I've always looked at that. So don't look at science as the enemy. Embrace it. To me, it is a gift from God that we can learn more about our world and how the whole thing is set up. All right, that's a topic for another day. So we're starting off with this model, and we know that the analysis is flawed, even to a minute degree. Now, do you remember, maybe some of you that are older like me, what we did in the old days was we talked about a range. We might say on television, the high tomorrow will be 78 to 82. Well, the consultants who are highly paid people to tell television stations how to do their job When in reality, the people within the four walls of that TV station know just as much, if not more, about how to do things. They told us that no, give a specific number. It sounds more accurate. Well, let's say I predict the high tomorrow at RDU to be 90, and I hit it on the button. I didn't hit it on the button for everybody, because you know what? Some of you were 88, some of you were 89, some were 91, some were 92, okay? One number doesn't fit all, but it sounds more accurate. That's what we need to do, right? Okay, you know how I feel about that. Now, we talked earlier about how models are mathematical equations, and I used to give school talks to first and second graders, okay, and other grades too, but I'm using first and second as an example. I would ask them, how many have heard of the word calculus? A couple of them say, yeah, I heard that. And I said, okay, let's pretend you're old enough to drive, and at 8 o'clock, your car is going 10 miles an hour. At 8:01, it's going 20 miles an hour. And at 8:02, it's going 30 miles an hour. So this is a very old car with very limited acceleration ability or potential. If that trend continues, how fast will you be going at 8:03? Well, I ask them, do you know see what's happening here? And they say, yeah, it's going up 10 miles an hour every minute. Right. So if you're going 10 at 8 o'clock, 20 at 8:01, 30 at 8:02, if that trend continues, what's it going to be at 8:03? So it's going to be 40, right? I had to think about it for a second. So you made a prediction about the future based on something that you already knew, a rate of change. And what mathematical models do is they use these differential equations and they look at how one variable is changing with respect to another, and then use that instantaneous rate of change to make a prediction about the future. And that's basically how models work. They use calculus and differential equations. So, we already talked about the fact of this perceived accuracy, okay? Well, supposing that we admit that our analysis is not perfect and those errors are going to multiply with time. So why don't we take the same base model, like we talk about the American model and the European model, take the same base model and change the initial conditions just a little bit to allow for the fact that our analysis is not perfect. And we change it to 30 different extents, very, very small incremental changes. And with the European ensemble system, 50 different extents. Well, if all the solutions 3, 4, 5 days out are very similar, that means we have high confidence in the forecast. If they're all over the place, like a finger painting exercise, then we have low confidence in the forecast, okay? Now, my fear is that people are going to look at this and they say, wait a minute, back in the old days, you had some guts. You committed to a number. You committed to whether or not it was going to rain or not. Now you're using words like uncertainty. You've taken a step backwards. No. Ensembles are one of the biggest technological breakthroughs ever in the science of meteorology, because when we made a forecast before, we had no way of quantifying how confident we were or weren't, okay? And if I'm a consumer, if I put myself in the role of a consumer, and somebody tells me I have high confidence in the forecast for the weekend, then I can go ahead and make detailed plans. But if that person tells me that they have low confidence in the forecast, I'm probably going to take a step back and say, hey, I'm going to wait a couple of days and see how this plays out. And maybe things will clarify a little bit in a couple of days, and then I can make detailed plans. But I'm not going to do it now if the meteorologist is telling me that the confidence level is low. That to me is useful information. And I got to tell you, I'm just being honest with you, I got a lot of good feedback over the years when people said, Greg, I remember that time you looked straight into the camera and said, you know, folks, I honestly don't know how this is going to play out. Here are the 3 most reasonable options, but I can't tell you with any certainty right now how this is going to play out. That's honesty. I was told by a consultant one time, and I'm quoting, never talk on television about what you're not sure of. Okay? I 100% disagree with that. I think you want to know how confident I am or any other meteorologist is, because then you can plan accordingly. And that's something we were not able to do before the advent of ensembles. Okay? So for the first time in the history of the science of meteorology, we had a way to quantify the level of confidence that we had in a forecast. Okay? So in summary, ensemble members are the same base model. For the American model of GFS, they have their own ensemble system. European has its own ensemble system. It's the same base model, slightly different initial conditions to allow for the fact that the analysis is not perfect. And then you run all those members along with the base model and see how sensitive the atmosphere is to those small tweaks. And the level of spread of all those ensemble members allows you to quantify how certain or how confident you are in that forecast. And I would argue that that is information that you want to know. Now, if you disagree with my take on this, leave a comment down below and let me know that. Or if you agree with it, let me know and put a comment down below. But I thought instead of showing you a bunch of charts and numbers and graphs and all that sort of stuff, I just wanted to pretend like we're standing in the hallway having a discussion, and maybe you're learning some stuff from me and I'm learning some stuff from you, okay? And that's the way I decided to do this. So I hope it was at least minutely useful, but let me know how you feel about it. All right, folks, that is bonus weather video numero 1 for this week. We'll have another daily weather update for you tomorrow, another bonus weather video as well. Hope you'll join us for both. So y'all take care, have a great Monday evening, and we'll talk to you soon. Take care.